Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and often in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. Today's episode is the next in our In Their Own Words oral history series, in which we talk with scientists who've made great contributions to their fields, particularly in the biological sciences. This week's guest is Gene Likens, Emeritus President of the Cary Institute of Ecosystem Studies and a distinguished professor at the University of Connecticut. He's also a past president of AIBS. Let's go to the interview. Dr. Likens, thank you very much for joining me today.
I'm delighted to be here, and you forced me to think about some things connected with AIBS that I hadn't thought about in a long time. So glad to be here.
Well, that's great news to us. Our first question is, when did you first know that you wanted to work in the life sciences?
Well, I've really had a lifetime interest in nature. I grew up on a small farm in northern Indiana, and as a young boy, I spent a lot of my time in the fields and the woods, as we call them, and the ponds and lakes around the farm. And so I've always had an interest from my earliest recollections in nature. But it probably wasn't until my senior year in college that I decided to do it seriously. I was until then thinking I was going to be a high school basketball coach and maybe teach biology or something. And it wasn't until the senior year that I decided to go on to graduate school and do it all professionally.
Was there anything in particular that happened in that senior year of college, or was it just, the interest grew over time?
No, there was something specifically that happened. From my earliest recollections, I wanted to be a professional baseball player. I can't tell you exactly why, but that's what I always wanted to do. And so I had pursued that as a child by trying to hit small pebbles with a stick because we didn't have a bat. And I thought, well, okay, if I can hit a small pebble with a stick, I can probably hit a baseball. And then I got a chance to play professional baseball for 2 years in what was called the rookie leagues. And I did that and really enjoyed that, did well, but I decided that isn't what I wanted to do. And so I did that when I was a junior and senior in college. And so that's when I decided that I was going to go on to graduate school. I also have to say that one of my professors, Emerson Niswander at Manchester College, had been pursuing me aggressively that I had to go on to graduate school. And I said, no, I don't want to go on to graduate school. And he pursued me. And I said I was in northern Indiana. Manchester's in North Manchester, Indiana. And I needed to drive to South Bend, Indiana to Notre Dame to take the graduate record exam. Which was really quite an ordeal, but I did it. And so that all came together, and I went on to graduate school at the University of Wisconsin-Madison.
And what did you study initially there?
Limnology. I was always interested in lakes and water. When I first went to Wisconsin, I wasn't at all sure what I wanted to do. But I was assigned a major professor, Arthur Hassler, and listening to him and following some of his interests, I got really interested in doing that. I remember specifically in the fall semester of my first year as a graduate student, being in one of his classes, and I was sitting way in the back, probably the back row. And he was talking about studies in northern Wisconsin of lakes. And so after class was over, I went up to the front and I said, Dr. Hassler, I really enjoyed what you were saying about your research in northern Wisconsin on the lakes there. Can you really get paid for doing that kind of work? And he laughed and said, well, yes, you can. Actually, I have a graduate student that's going to Northern Wisconsin this coming weekend. If you'd like to ride along and see what he's doing, you can. I did. I got hooked, and that led to my career.
That's fantastic. And what sort of research was being done up at those northern Wisconsin lakes?
Well, a number of things. One of the things that really interested me was the manipulations of lakes. In that case, they were trying to circulate lakes to make them clearer. These were acid bog lakes, and so the coloring in the water prevented sunlight to penetrate, and the productivity was low, and the fish production was low. So attempts were made to circulate the water with chemicals like lime or hydrogen peroxide or whatever to precipitate out the dissolved organic matter and make the lakes more productive and shift their fish populations. And so that experimental approach was really very interesting to me.
What would you say was the biggest surprise of your career?
Of my whole career, I suppose the discovery of acid rain at Hubbard Brook. The very first sample that I collected at Hubbard Brook in June of 1963, we were just starting our large Hubbard Brook ecosystem study. In that first sample, the rain, is in June of 1963, was about 100 times more acidic than we thought it should be. We really didn't know what it should be because there weren't data for comparison, but it seemed exceptionally acidic. So we were very puzzled. Where was it coming from? How did it get that way? How long it had been that way? Did it have any ecological effect? And on and on. So I would say that's probably the biggest surprise in my career.
And what was that moment like? Is this one where you rerun the test 10 times?
Oh, yes.
Bring other people into the room, or it sounds like it would be shocking.
It was shocking. And in fact, at that time, 1963, the measurement of pH in just water was rather difficult. And we did it with a soil pH meter, actually, a Model G Beckman pH meter, as I recall. And so, yes, we had to rerun it and then collect other samples. And it was a big aha moment. Wow, what is that? Is it? And we didn't know whether it was really significant ecologically at all. The theoretical idea was that at ambient concentrations of carbon dioxide in the atmosphere, the lowest pH should be about pH 5.6 or so in pure water, in distilled water. And this was 100 times or so more acidic than that. But was that important? Did that have any impact? And after all, it didn't rain all the time, and the amount of rain was sometimes very small, and so forth.
And what were the months and years after that, validating that finding and, searching out the acidity of rainwater elsewhere? Like I recall at least reading one story in which you were flying around in a plane, perhaps, reaching out the side of it and sampling directly from clouds.
Well, that's correct. It's a long story, but trying to find any other people that were working on acid rain, we didn't generate that term until our first paper. So from that first sample in June of 1963, we didn't publish the first paper until 1972, so 9 years later. It took us that long to try to understand what this was all about initially, and whether it was real and all of that. And it was in that paper that we titled the paper Acid Rain. And the three of us authors, I'm the first author, and Herb Borman and Noy Johnson were co-authors. And we argued a lot about what the title of the paper should be. And I argued that well, we really didn't want to call it the acidity of precipitation in New England. That just didn't have much impact, I argued. And I prevailed. So we just called it acid rain. And that really caught on as something that was understandable, and the image of what acid rain was to the public. So that was an important title, I think. So we had to try to find out, as I said, where it came from, how long it had been that way. So later on, during this 9-year period, we were trying to understand all of that. So working with colleagues at the National Center for Atmospheric Research in Cary in Boulder, we used one of their small planes and flew through plumes of emissions from the power plants in the Midwest, places like Ohio and Indiana and Kentucky. And very primitively opened the window of the small plane and held a funnel-like collector out the window and collected some of the pollution plume to try to get an understanding. Our idea was that these large-scale emissions that were occurring in the Midwestern part of the U.S. were being transported by generally winds from the west to the east, and was falling, and that precipitation was falling then down as polluted rain on our environment in the eastern U.S. And so that was an attempt to try to find out if that was true. We did later on use some isotopic work to more sophisticatedly analyze what was going on. But there were many things like that. How long it had been that way, we set up with colleagues. I set up with colleagues collections in some of the remotest regions of the Earth, the southern tip of Chile, the southern tip of South Africa, an island called Amsterdam Island in the middle of the Indian Ocean. It takes a month by ship to get there. There was no landing strip there then. A remote area in Australia and so forth. And we collected rain in those areas for 10 years or so in each of them in order to try to answer the question of what the rain was like before humans changed it. And the number we came up with was a pH of 5.1. So then that's the reference that we use for what it was prior to major human contamination.
And was that the result that was published in the initial paper, or was that something that came along a little bit later?
Much later. The initial paper was just laying out that there is such a thing as acid rain, and what its ecological impacts might be. That was in 1972 and 1974. By that time, I had moved from my first academic position at Dartmouth College to a position at Cornell University. And there I set up around the Finger Lakes a series of sampling collectors and determined that the acidity, the pH of rain and snow throughout the year was essentially the same around those Finger Lakes as we had been measuring at Hubbard Brook. So that was the first clue that this was a regional problem. It wasn't something just at Hubbard, some unusual thing just at Hubbard Brook. And that leads me to say about the role that serendipity has had in my life and in my career. If I hadn't moved to Cornell and if I hadn't set up those collectors, we wouldn't probably have had that insight about the regional nature. So we published a paper in 1974, 2 years after the acid rain paper in Science, and suggested this was a regional problem and that the main source was the Midwestern power plants.
And this may be something that we'll get into later, depending on the answers that you have in mind. But how did that then transition into advocacy and political involvement? Because it's not often that a primarily scientific story like that reaches such a broad audience. And, I certainly recall discussions of acid rain from my childhood in the 80s. It's probably the first conservation or ecologically related story that I ever heard in my life. And so, how did you get involved in that respect?
Well, I think it's actually very rare that you live long enough or conditions evolve in a way that you're there from discovery to political action. And I've been fortunate to do that with the acid rain issue. So discovery in 1963 to political action, the Clean Air Act amendments in 1990. So I'm very fortunate to be in that rare group. I just happen to live long enough. So the issue then, after we published that paper in Science in 1974, that paper was featured on the front page of the New York Times the day before. So that really was very visible, obviously. And I had calls, it was calls back then, and letters from people all around the world saying, Likens, what is going on? What is this stuff that's going on? And of course, then soon after, the finger we pointed at the Midwestern power plants were saying, oh, no, 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 not us. We didn't do it. We're not the cause of acid rain. And we were saying, yes, 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 you are, as far as we can tell. And that's the time when we did the sampling from the small plane, trying to trace those pollutants. We also had, adding to the small plane, we also had a van on the ground that we would try to follow storms and hoping that it would rain, because whenever it would rain under one of those plumes or near one of those plumes, we'd stop the van and jump out and grab our collectors and try to get a sample of rain and then move on. At any rate, so that's when the issue about relevance to management and federal regulation started to appear, and that story, I think, is fairly common with environmental issues that have had this kind of trajectory. For example, DDT with Rachel Carson, lead, pollution, maybe eutrophication of freshwaters, smoking. So the finger pointing at the source, and then the vested interest at that source saying, no, 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 not us, we didn't do it, and mounting a huge campaign to raise doubts about that finger pointing. That's really where it started in terms of the relevance to management.
And what's it like finding yourself in the middle of a conflict like that? Because I mean,
Yeah.
I know you don't, you certainly don't sign up for that when you enter a career in science.
Well,
it's not the expectation necessarily.
Yeah, I don't think you do, and you also, and particularly in that time, I had no training for how to say testify to a congressional committee or to to respond to a rude event. For example, I was giving a lecture once at Eastern Kentucky University, and I had just started to talk, and I was talking about acid rain, and the back doors of the auditorium literally burst open, and this live camera crew came bursting into the auditorium with their bright lights flashing, came right down to the front, shined their lights into my eyes, and started to ask me questions with a microphone shoved right in my face. Well, I'd never had anything like that before in my life, and did I know how to respond to it exactly? So it was very different, and I had to learn quickly, and I had to learn about things that were not science per se, but science education. And yeah, it was a interesting, somewhat scary time. The 1980s I've called the acid rain wars because that was the period in which the Reagan administration was pushing back very hard, um, uh, trying to show that there was no such thing as acid rain, let alone having any impacts. Does that remind you of anything now?
Unfortunately, so.
and having to meet those challenges at all levels was interesting, difficult. But looking back on it, um, you learn quickly. You learn quickly how to adjust.
Yeah, absolutely. And obviously, at least to some degree, this is something of a success story because there have been reductions in acid rain.
Oh yes, oh, yeah, yeah. Currently at Hubbard Brook, for example, the acidity is about 80% less than it was when we started to collect samples in the 1960s. So that's a huge success story.
Yeah. Do you have any advice for scientists who may find themselves in these sorts of unexpected positions of advocacy and arguing for a greater conservation?
Yeah, I've always said I think you should speak out, but I think you should speak out about things you know something about. That sounds like a trivial statement, but it's not. Um, and if you speak out about things that you know something about, and particularly if you know you're going to be interviewed by a reporter, there are some things you can do to help clarify your message and get your message across. You could hand out a one page um, or email a one page to the reporter that's interviewing you so that you can get your facts out the way they need to be clearly. You could provide a photograph of your research. You could provide the caption for the photograph and things of that sort that keep you on topic when uh, the camera goes on. To me, there's nothing much scarier than when the red light of a television camera goes on and shoved right in your face and you're on live. And I've done that many times, and you just have to stay on topic because very often the reporters want you to go off topic.
That being when they get the good quotes,
That's right.
but not necessarily the good quotes for the scientists necessarily.
Well, sometimes you say things that are misused or not exactly the way you meant them. And so that's one of the advantages of having a one pager that you could hand out to a reporter. These are my points. This is what I want to say.
I think that's excellent advice. What would you say is the biggest difference between the way that science is conducted now and the way that it was when you first entered the field?
Actually, I'm laughing because we didn't have cell phones, we didn't have computers, we didn't have the internet. Uh, uh, I had to build a lot of my own research gear because I couldn't go buy it somewhere, or I didn't have a machine shop to have it made for me. So I largely built the things that I needed in the field to work on. And yeah, that's all different now.
And do you miss that ad hoc experience ever of, having to kind of make things up as you go?
Oh, I do. I do. And I really think that I learned a great deal from, say, building an instrument to do some sampling that I needed to do in a lake, for example, because I had to think really very hard about, well, what is it I'm trying to do here? And what do I need to do it properly? And I think that forced me to do it better. So yeah, I do miss that.
Although I guess the tinkers of today are now largely working on software, but I wonder if the experience might be similar in some ways as well.
Well, not being a software tinkerer, I can't answer that question, but it may be. I don't know.
It certainly could be, and I wouldn't know either. Let's talk about professional societies a bit. What sort of role have they played in your career? And, are there any standout events?
My major professor, Arthur Hassler, that I mentioned previously, um, for whatever reason, felt it was important for us graduate students to be involved in professional societies. So he urged us to do that and encouraged us to do that. So I've been a member of a professional society or several since about 1959. And the very first society that I was a member of was called the Midwest Benthological Society. And the first meeting that I remember going to was in Minneapolis. I gave a paper there, and I was just starting my graduate work at that time. That had been my second year. And I've been a member of professional societies, many, ever since. And I think they have been hugely important to my career. The exchange of information, obviously, very important, but the interaction with people, the learning of new ideas, not only in the formal sessions, but in the informal discussions, the meeting of new people, the developing of friendships and colleagues that I could work with. Much of my research has been with multi-colleague investigations. And so some of those colleagues were recruited by me through meetings, developing friendships and saying, hey, wouldn't you like to come join this new thing that I want to do? And and I guess being able to travel, the International Association for Theoretical and Applied Limnology has until now met every third year in some location throughout the world. And having the opportunity to see those locations all around the world have been hugely informative to me. To see lakes and their surrounds all around the world just gave me a totally different perspective that I never would have had without the opportunity for that travel. So that's another component. So yes, scientific societies have been really very important to my career. I've been fortunate to lead 4 of them as president, including AIBS, and I found that an interesting challenge, but also a very enlightening challenge. And again, the opportunity to meet and interact with diverse people.
And do you have any perhaps favorite stories from your time working with AIBS and leading AIBS, in fact?
Well, I think when Gregory Anderson, the University of Connecticut, was president, he probably suggested me as a possibility for the presidency. And when I was approached, I think I said something like, oh, that's nice, thank you, but I'm just way too busy. I couldn't possibly do that. But at least I'd have to ask my wife. and then I did it, and I found time to do it, and I really enjoyed being a part of AIBS. Kind of a funny story, at least it was funny to me. I was presiding at the awards ceremony in Washington, D.C., and I was presenting an award to Stephen Jay Gould. And in the audience, there were a lot of people there, but near the front was a very distinguished scientist, Bruce Alberts, who was then president of the National Academy of Sciences. And right in the middle of my presentation, a cell phone went off. and Bruce's wife smacks him in the arm and said something like, "Bruce, I told you to turn off your cell phone." He fumbled around looking for his cell phone. I mean, just disrupted. He fumbled around for his cell phone and he pulled it out and he didn't, no, it's off, it's off. And so we went on. Well, then after that session was over with, my wife, who was sitting right behind Bruce Alberts, came up to me and she said, that was my cell phone that went off. So little things like that. Not very important, but they stick with you for a long time.
That's very funny. And actually, Dr. Anderson told the story of recruiting you for.
Oh, he did. Well, I'm sure
he
was the one, but and I'm glad he did. But I at the time didn't think I possibly could add that to what I was doing, but I'm glad he did.
Yeah, he reported that he successfully convinced you and also called your wife and thought he'd been successful in convincing her that it was a good idea, and found out later that perhaps she thought that you were already rather busy. Moving on, what would you say is your most challenging day on the job?
Well, I have really loved my job. I can't honestly think of any day I've ever gotten up dreading to go to work, because I don't consider it work. I consider it fun. And so I have been very fortunate to have a job like that. So many people dread going to work, and to not dread going to work, I think, is a huge benefit and kind of an honor that I was so lucky to get that kind of work. But maybe I was president at the Institute of Ecosystem Studies in Millbrook in 9/11, when the World Trade Center buildings were bombed by the planes. And when we got that news, I called all of the employees. We had about 100 employees at the Institute. I called all of them together in our auditorium, and I had to try to find some words of consolation and hope. And I remember that being really, really difficult. But that was a part of my job, and I think I did it okay. Hopefully well, but I think I did it okay. But that was a tough day on the job.
Yeah, I can certainly imagine. Was there an impact then to your work directly as a result of 9/11, or were you geographically distinct enough?
Well, we're about 2 hours drive from Manhattan. Millbrook is about 2 hours drive from Manhattan north. But we did have a fog collector. We were analyzing the chemistry of fog water, and we had a fog water collector on one of the towers. And so that obviously ended that work. So in that way, it affected me and my colleagues, but that was minor to all the lives that were lost, of course.
Of course. And now making a complete 180-degree turn and looking at the absolute other side of things, do you have a best day on the job?
No, that's a tough question, because I said already that they all were great. Well, okay, a kind of maybe funny story. So this is going to be maybe a little longer than you wanted. But so when I was a graduate student at the University of Wisconsin, I was in a graduate student office with about actually 4 other grad students, and we were right across the hall from Professor Hassler's office. And one day he knocked on our door and came in, and he said, "I just got a call from Dartmouth College, And they've had a faculty member that suddenly has had to leave, and they're looking for a replacement, someone to teach aquatic ecology during the fall semester. This was during the summertime when Hester came into the office. And if any of you would be interested, let me know, because they're desperate to find somebody and would like to do that soon. And turned around and left. All of the students and we looked at one another, and I'm not making this up. We all said, "Where's Dartmouth College?" we didn't know. We were Midwesterners, and I guess totally naive Midwesterners. So I had above my desk on a shelf the collegiate Webster's dictionary. I pulled it down the back. There was a listing of all the colleges and universities in the country, and looked up Dartmouth, and it gave their location and date of origin, whatever. And then it said all men. And I read this out. And then the group really thought that was funny, because we weren't familiar with any kind of all men or all women colleges, and Dartmouth was all male at that time. Well, I ended up going because I had the fall semester available to do that, and I thought it might be fun. And it turned out to be. And I mentioned serendipity before, but if that serendipitous event hadn't happened and I hadn't gone to Dartmouth College, I wouldn't have been able to found the Hubbard Brook ecosystem study, and I wouldn't have discovered acid rain, and on and on and on. So that was a very big day in my life, looking back on it. Totally unplanned, totally driven by serendipity. I define serendipity as keeping your eyes, ears, and mind open. And if something interesting comes along, you jump on it and try to make something of it. So I guess that would have to be a time that I would say was very significant in my career.
Yeah, absolutely. And I think that nearly leads into this next question, and we may put a twist on it. But what event from your career do you think will be best remembered long into the future? And obviously, the discovery of acid rain is perhaps even more than a front runner. But if not that, what would you like to be remembered from your work?
Well, I think you're right about acid rain. I think that is a very significant study, and the fact that we were able to get to federal regulation and management that has now reduced the problem, that makes it a success story. When I'm introduced for a lecture or an event of some sort, usually the introduction focuses on the fact that I was a co-founder of the Hubbard Brook Ecosystem Study and the founder of the Institute of Ecosystem Studies. Not so much about any awards or how many papers I've written, but it's those two things that are usually mentioned. I recently, in November, gave a major lecture in Vienna, Austria, and that's the way they introduced me, just that way. And it got me to thinking about, well, I guess that's maybe among the most important things I've done. And that's really not so much about me. It's about all the people that have now worked through Hubbard Brook as students and colleagues and technicians, and what they've learned there, and then all the people that have worked through the Institute of Ecosystem Studies, now called the Cary Institute of Ecosystem Studies. That impact I'm very proud of.
And what do you think makes Hubbard Brook so special?
Well, I think we were early on in terms of trying to understand how large-scale systems work. We certainly were early on in doing large-scale experiments at the watershed scale. I mentioned earlier today that at the University of Wisconsin, I was really taken by the experimental approach that was being applied to lakes in northern Wisconsin. And that really stuck with me because doing experimental work is so powerful in science. And to be able to do it on natural systems and large scale natural systems is just, in my view, an extremely powerful way of doing that kind of science. So I took that approach to Dartmouth, and with my colleagues Borman and Herb Borman and Bob Pierce and Noe Johnson, we were the founders of the Hubbard Brook ecosystem study. I argued very aggressively and successfully that we needed to do large experiments at Hubbard Brook. So the very first one we did was to deforest an entire watershed. It wasn't a logging operation, it was an experiment. And that experiment is discussed and reproduced in essentially all the major biology and ecology textbooks currently. So I guess that's what I would say.
One might think of it as one of the very early large-scale outdoor laboratories.
Right, right, and it of course the discovery of acid rain there was or is a part of that, and I think the approach that we took, where we tried to look at what I call air, land, water interactions. So it was the atmosphere, the terrestrial system, the aquatic systems, both streams and a lake in the valley that we've done a lot of studies on, Mirror Lake, trying to combine all of those things and talking about airsheds and watersheds, trying to take that scale up to those levels, but in a quantitative way.
Yeah, and is the element of time particularly important there too? Because a lot of the work has been carried out over years rather than a shorter scale experiment.
Well, that's right. Our long-term monitoring efforts have now given us insights that we'd never gotten from shorter-term studies, and so I think we're 57 years of continuous monitoring of precipitation and stream water chemistry and hydrology done by the U.S. Forest Service, and integrating all of those over a long time period, as I said, have just given us insights that we wouldn't have gotten, I don't think, any other way, because we do modeling and we do plot studies and we do on-ground studies or in lake studies or in stream studies, but it's that long-term monitoring that says, oh wow, look at that, how did that change and what caused that to happen, and then you can go into the system and try to answer that.
That's really interesting. What's the most frightening or intimidating thing that's happened to you in your career? You've mentioned at least one of having the red light of the camera put in your face, but does anything else spring to mind?
Well, when I was this young, very naive graduate student that didn't even know where Dartmouth College was, and then I went there as a young professor. Actually, I was my first position was as instructor, and New England is very different than the Midwest. Not just in cultural things, but the water is different. The water, it has low calcium, magnesium, bicarbonate content, whereas the Midwest, it has relatively high calcium, magnesium, bicarbonate content. So all that I thought I knew about water and water analysis and water sampling all had to be relearned. So it was pretty intimidating as a very young, naive scientist going into that environment at Dartmouth. And Dartmouth had just changed from a department of zoology and a department of botany into a department of biological sciences. And frankly, the zoologists and the botanists didn't like each other much. So I walked into that situation, and I was being courted from both sides. And as an ecosystem ecologist, one of the reasons I went into ecosystem ecology is because I couldn't decide what I liked better, botany, zoology, and I didn't have to as an ecosystem scientist. So they were trying to court me to join their side of the equation, and that was all very strange to me. So that was intimidating, but I worked my way through it.
So it sounds like a little bit of a culture shock.
It was, and then there is a big, and more so then, a big difference in New England and the Midwest. The big fields of corn and soybean and whatever in the Midwest just don't exist in northern New England.
What are you working on right now?
I'm working on a number of papers. I'm retired, but actually retired twice, but I can't quite figure out what that means. So I'm working on a number of scientific papers by myself and with colleagues. I'm working on a book slowly. I'm calling that the IES story, IES being the Institute of Ecosystem Studies, because I think that has an unusual story in terms of the formation and some of the things that I tried to do there. Securing an absolute top-notch faculty, but not offering them tenure and not offering them a startup package. And it worked really very well and made us, in many ways, stronger, more cohesive than I think if we'd gone the other way. So I'm trying to capture some of those things that I did that led to the success of the Institute of Ecosystem Studies.
Now, and obviously without scooping your book, but what are some of the impacts of having a system like that without large startup packages and tenure?
Well, for example, I think this is a good example. If you give somebody a very large startup package, then, and often they, not always, but often they need to be spent in a certain period of time, maybe 2 or 5 years or whatever the time might be. And that's hard to do, particularly as a young scientist, to know what you want to do and whether you want to buy this $1 million instrument, and is this going to be the way you really want to put a lot of money out or what? So I told my incoming faculty that I wasn't going to give them a startup package, but I didn't plan to go away, and anything they would need, I would provide. And so it was a startup package that I held. So for example, then, if they needed a fancy, very expensive piece of equipment, rather than rushing out and buying it, we explored whether anybody else in the Institute might need the same piece of equipment, and whether we could buy one and have it be shared and operated jointly. That worked beautifully. It really worked beautifully. So that there wasn't, a fancy instrument, one right next to themselves in adjacent rooms halfway down the hall. So that's an example of how it really worked well.
And the role of tenure, or the absence thereof, how did that play into things?
I offered them a 5-year appointment, renewable, and at the end, or in preparation for that renewal, they were asked to indicate what they had done in the previous 5 years and what they plan to do in the next 5 years. They were asked to identify only 10 of their best publications during that period. And then I sent those packages out to the best people that I could find anywhere in the world. And I essentially asked the question, are these the best people anywhere that I can find to hire at the Institute of Ecosystem Studies? And we hired well, and the answers always came back, yes, these are top-notch people, hang on to them.
And moving along to our last couple of questions, if you were entering graduate school today, is there anything that you would do or study differently?
Well, given what I've said before, probably not, because I've been very fortunate to have things work out well, and by well, I mean that I really enjoy what I do. It's fun and not work for me. It's fun. But also, I've said that I probably still am, very naive. And I think today I wouldn't be that naive. I think times are different. And with the access of information through, say, Google or whatever, we didn't have that kind of access. There are downsides to that too, in my opinion. But yeah, I'm happy with the way my career developed and progressed. I'm very fortunate.
And you've given us already a bit of a primer on, some media training for young scientists. But do you have any other advice for people who are just entering the field?
Sure, but let me go back to the media training a bit. University of Connecticut, where I'm currently teaching part-time in my retired position and enjoying it actually very much. I'm there in the fall semester. UConn has a very active program and a course, maybe more than one course, in which they combine journalism students and journalism professors with ecology and evolutionary biology students and professors. And they talk about how to talk with the media and how to interact with the media. And I think this is terrific. They practice meeting with a journalist, and they bring in well-known journalists to work with them and to help them. Wow, I would have loved to have had that exposure and experience when I was, well, anywhere as a graduate student, but as a young faculty member particularly. So advice to young people in general, maybe, but students, is find time to think and to think deeply. I'm actually concerned, worried, maybe too strong, that the pace of life these days and the activities that we're expected to do really don't give us a lot of time to think deeply unless you really make that time. So I think my advice would be make that time to think really deeply, because as a scientist, that's what it's really about. It's not rushing to the next meeting when we can again in India or somewhere. It's thinking deeply about some issue and thereby making progress toward understanding. And then I guess the other thing I would say, again, it's trite, but it isn't, don't ever give up. And it's easy to give up, particularly on hard problems, but don't ever give up.
Well, that's great advice, for now more than ever, and I think a good note on which to leave it. Dr. Lykins, thank you very much for joining me today.
Thank you.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.